Welcome to our video lecture on arrays, where we'll be talking about storing multiple related values all in one variable. So we'll begin with a bit of review. In previous classes, I mentioned that computer memory is a little bit like mailboxes at a post office. Each of those boxes has an address, and it also has contents. The address is basically a label on the box, and the box itself holds information. In my case, I get a lot of bills inside. In your case, perhaps you get letters and cookies from family. Computer memory, though, isn't actually a physical box. As we learned before, it's a tiny circuit made of transistors that store binary numbers, ones and zeros. Much like the post office boxes, each memory element has an address, which we usually express as a hexadecimal number. So the coding problem that we want to address using arrays is if we have a lot of related information, for example, student grades, and we want to store this related information and do some analysis on it. So for example, if we have a pretty good first-term student at Seneca that's only messed up one class, their marks might look like what's shown below here. Right, whereas 48.8 was a failing grade, that's the one that they messed up on, but my hope is that this student got 91.1 in IPC 144. So these are some example grades. Let's flip over to our sort of code land, and we'll talk about trying to implement this using the tools that we've learned so far. In order to demonstrate the usefulness of arrays, first we're going to try to solve the problem of storing the related information of some student grades for one student for one term without using arrays. So I'm going to create a new file. I'll call it array grades.c. So the purpose of this program is going to be to get several grades from the user and store them. Well, we're going to at first try to store them in variables. Then when the user is finished entering grades, repeat, or rather we can say display the entered grades in the same order that the user entered them. Right, so we're going to ask the user to enter the grades, and then we're going to basically repeat those same grades back to the user. Sounds like a pretty simple problem, but we're just beginning with sort of simple things at first. So like any of our programs, we're going to include stdio.h. We're also going to have our trusty int main void function. Right, and inside this function we're going to return 0 at the end. Okay, so if we want to store grades, we basically, just like every other program we've written so far, we're going to need to have variables in order to store those grades. So because we're talking about grades as sort of fractional numbers, we're going to use floating point numbers to represent those grades. So for my first grade, I'm just going to name it, well, let's put a comment here first actually. Declare variables to store grades. Okay, here we're going to go ahead and do that. So I'll say float. For first grade, I'll call it grade 1. Right, number it that way, and then we're to have a variable for grade 2, float grade. Here I misspelt it. Float grade 2, float grade 3. Have to be a little bit more careful when typing. Float grade 4, float grade, do it again, grade 5, and finally float grade 6, giving us enough storage to store all of those grades. Okay, and then it comes time to, we can put some comments here, get the grades from the user. And finally, the last step is going to be display the grades in the same order that they were entered. Okay, and even though we're going to be able to solve this without the use of arrays, I want to show you how tedious it's going to be in order to be able to handle these 6 grades. And by extension, if we had to say store 100 grades, right, or maybe perhaps 50 grades for a student that's been at Seneca for a few terms already, or if we wanted to store all of the grades for all of the students at Seneca, I want to demonstrate that it's going to get very tedious in order to do that. So let's get started here by getting the grades, getting the user to enter these grades. And so here we're going to prompt the user just like we've done every time before with printf, enter the first grade. Okay, and then we use scanf in order to read that in. Scanf, and I'll say %d. Sorry, we're using %f because as you'll notice that we're using floating point variables here, so we use %f with floating point, and as always I have to provide the address of my variable, grade 1, and that takes care of reading in grade 1. Then we have to do the same thing for the second grade, printf, enter the second grade. Scanf, and we use scanf. %f formatting, character, and now we're going to read it into grade 2. And as you can see, this is already kind of getting a little bit tedious, right? We can do the third one here. Actually, I'm going to use a little bit of copy and paste magic here. I'm going to copy that. I'm going to paste it a couple times here. That would be, so here's this going to be for the third grade. Changes to grade 3. Enter the now we can do the fourth grade. This is going to be grade 4. Oops. Okay, here we're going to do the 5th grade. And finally, we're going to do the 6th grade. Right, so these are going to be all the grades for one student for one semester at Seneca. So now that we've read in all the grades, right, the next step is to display all those grades. So here we're going to display the first one. The first grade is, and then we're going to leave a placeholder here for that grade. New line, and we will say grade 1 for the first grade. So I'm going to use the cut and paste that's built into Nano in order to give us these 6 lines. So we're going to say the first, second grade is grade 2. We can change these really quickly. 3, 4, 5, and 6. And over here, we're going to change these. Third, fourth, fifth, and 6th grade. So we've written this out in order to be able to handle 6 grades, but now you can imagine, we would need to have a printf and scanf, and also a printf here at the end for every single grade that we're doing. And you can kind of imagine that if we were doing 50 or 100 or 1,000 of these, then it would get extremely tedious to write these lines. So some of you are probably already saying, well, wait, Professor Merrick, didn't we learn about loops last week, where we can use loops such as the while loop in order to repeat actions such as reading in grades or printing out grades? And loops are happy to go, as we showed in class, 100, 1,000, or even 1,000,000 times without getting tired. So let's take a look at trying to solve this same problem of reading in grades and printing out the grades by using loops, and still without using arrays. So what I can do is I can go ahead and set up, first of all, I'm going to get rid of some of these lines of code that we don't need anymore if we're using loops. Right, I'm just using Control K to delete lines here. Okay, I'll try to show what this might look like by using a loop. So the loop that we've covered so far is the while loop. So what I could do is I could create a counter. Right, counter is just a name I'm coming up with to indicate that I'm going to be using this variable in order to count things, in order to count grades. Right, and so we're going to start counting. Let's say we start counting at 1. Right, we're counting from grades 1 to 6, and I'm going to write a loop. So I'm going to write a while loop. While counter is less than or equal to 6. Right, so this will go through the loop when the counter is 1, 2, 3, 4, 5, and 6. Right, guaranteeing that we get through this loop 6 times. And what we can do is we can put all these statements here to ask the user a question and to read that data into a variable. We can put all those statements here inside the curly braces of this while loop. And as we learned in previous classes, all of the code inside here will get repeated as long as this condition up here is true. Right, so when writing this loop, we also mustn't forget that every time through the loop, we have to increase counter by 1. Do you remember the shorthands that we introduced last week? Right, so we could have rewritten this in a simpler way. Just as a reminder, a bit of review. But the problem comes, right, if I can express the idea to tell the user which grade they're currently entering. Currently entering grade, and here we'll leave a placeholder for that. Okay, and here we can print out which grade we're currently asking the user to enter. And that's just simply our variable counter. Here I'll just say, please enter grade. Okay, the difficulty here comes when it comes time to use the scanf function in order to read some data into one of the grades. Right, you'll notice up here I have my variables declared: grade 1, grade 2, grade 3, grade 4, grade 5, and grade 6. Down here I would have to write an if statement, right, saying something like this. I'd have to say, if counter is 1, then what we're going to do is we're going to read information into the first grade. Right, and then I would say else if counter is 2. Then I would read information into the second grade. Right, and I can continue writing if and else if conditions basically for every grade. And you see, by doing this, this is still extremely tedious. I have to write an if and an if-else condition for every possible grade. This is fine when I have 6 grades, but if I had 50, 100, 1,000, or 1,000,000 grades, I'd have to write out all this code. So the problem that we have to solve is how do I tell the C compiler to use a different grade every time through the loop, right? How can I store? Really, the question we're trying to answer is how can I store all of this related grade information in sort of a single cohesive piece of data? And the answer to that question is by using arrays. So let's talk about arrays and how they can solve our problem of storing related information together. So an array is a way to store related information under one variable name and enables us to access these multiple pieces of related information just by simply using an index. The index is like an address of the mailbox in the post office. This idea should kind of already be familiar to you because a couple times already, including the first class, we talked about computer memory or RAM as having the same concept of an address and also a value that's stored inside. But don't worry, because C is a high-level language, we don't actually have to worry about memory addresses directly in order to take advantage of the power of arrays. So we can start with a little bit of syntax. If I want to allocate space in order to be able to store multiple grades, I can declare a variable much like before. The syntax to declare an array is as follows. First, we specify the type, like with any variable, and then we come up with an identifier, which, as you remember, is just a fancy word for a name that the programmer comes up with. So for the identifier, you're going to choose a name that's meaningful for that particular variable. What's new here is, following the identifier or the name of the variable, we have square braces. And inside the square braces, we specify a size. And that size indicates the maximum number of things that can be stored inside that array variable. So for example, if I wanted to allocate space for 6 grades that I'm representing as fractions, so for example, in this case, 100.0 is a perfect grade, and 50.0 might be a passing grade. So in order to do that, in order to give me space to store 6 grades, I would write the following. Float, right, which is my type indicating that it can store fractional numbers, and then I write grade, which is a name I've chosen in order to describe that information, right? We're storing grades, so grade is a reasonable choice here. And then finally, because I have 6 grades to store, within these square braces, I put the 6, which ensures that the C compiler will make sure that we get enough space to store 6 floating point grades. So array indices, right? Indices is just simply the plural of the word index. In the C language, these indices always begin at 0 and go all the way up until 1 less than the size. So an example of this to think about is for an array of size 6, the valid indices start at 0 and then they go to 1, 2, 3, 4, and 5. You'll notice that 5 is 1 less than the size, and then the total number of indices here, or available elements, are 1, 2, 3, 4, 5, 6. There's 6 of them, however they're numbered 0 to 5 instead of 1 to 6. To initialize an array with some values, we can add a comma separated list enclosed by curly braces. So for example, our student grades from earlier might be represented like this. We'd write float, right? Again, the type is float, the name is grade, and we're indicating that there's 6 grades, and then what we do is we initialize them using the assignment operator. We have an opening curly brace, and then we have a comma separated list of our initial values. Curiously, this syntax, using the assignment operator in order to give our array of grades a set of values, only works when we are declaring our array. So this is only an initialization statement. This idea of using the assignment operator to assign a whole bunch of values to an array at a certain time, we can only really use this syntax when we're initializing the array for the first time. Sometimes students think that we can use this sort of idea later and assign a series of values to an array. Just be a little bit careful with this syntax. This assignment operation with the arrays only works when initializing that array for the first time. So that was a little bit of an aside, but it's sort of important to note that when you're writing your own code. So that's great. Here's how we can fill up an array, but how do we actually get at that data later? Right? So this is the sort of next point I want to talk about. After declaring the array, the data stored inside each array element can be accessed by using the square brackets. And whenever you see these square brackets in C, right, I want you to think arrays. Right? Whenever you see these square brackets, you should realize that you're dealing with arrays. So for example, if I were to write this little bit of code, grade, and then within the square brackets put index 0, this is how we would indicate that we want to access the first stored grade. Remember that these indexes, they start at 0, right? So the first one goes into 0, the second one goes into index 1, and so forth. So if I wanted to print out the first grade, I might say something like this: printf, and then my first grade is, having a placeholder for that grade, and then finally here at the back part where we normally put the name of a variable, we put the name of the array variable, but we have to specify which element of that array we want to access. In this case, the first one is at index 0. And so what I want you to note here is, because this index inside here, right, it can be a literal number or it can also be a variable. Because of this fact, arrays work very well with loops, as we're going to show in a couple minutes. So here's a pop quiz for you. How could we allocate enough space so that we can store one grade for each of the students at Seneca? And there's about 30,000 students at Seneca. So a long story short, if we want to save 30,000 grades, how could we do that? Pause the video if you want for a minute to think. Ready? Here's what we could write. Right? We could simply change that 6 inside the square braces here to be 30,000 if we wanted to store 30,000 grades instead of 6. Here's another pop quiz. How could we allocate enough space to store student IDs for 1,000 students? And let's assume that student IDs are whole numbers and not fractions. Again, take a moment to think and pause the video if you like. Ready? Here's how. Right? We could declare an array of integers, right? Of int, which is good at storing whole numbers. Here I named it student underscore ID. I'm sure you could think up an equally creative and descriptive name. And here we indicate that we can store up to 1,000 elements inside that array. So I want to talk a little bit about a conceptual drawing here, or an illustration which sort of talks a little bit about what's going on. When I initialize this array of 6 grades, what ends up happening is the operating system gets for us 6 memory elements, each enough to store one floating point number. And those are indexed starting with 0, 1, 2, 3, 4, 5. You'll notice that the index is a lot like an address, right? An address of the box. It's a label for the box. The index is not stored inside the box. The value is stored inside the box. Before we move on to actually using our newfound array powers and skills in order to solve that problem of storing and retrieving the students' grades, let's talk about what happens when we try to assign a value to one of those grades. In this example, let's pretend that this student we're talking about cheated on the final exam in whatever this course is at index 4, right? This one with 62.9. So what we can do is we can assign them a new grade for the 4th index, and we can assign 0.0 and store that 0.0 inside the grade at index 4. So what we would see that happens is that the assignment operator will store 0.0 inside index 4, and in that way we're able to change our data that's stored inside arrays as well as read it out. Okay, let's jump into some code and show how we can use our new array abilities. So coming back here to our code, let's change this example that we were working on to work with arrays. So I'm just going to make a note here that we're getting 6 grades from the user in the comment there, right? And instead of declaring 6 different grade variables, what we're going to do is just make one grade variable, but we're going to make it an array of size 6, and that's how we do this. So I'm not going to assign initial values to this array because immediately the very next thing I'm going to do is use a loop in order to read those values in and get the user to enter those values. So as we learned, array indexes start counting at 0. So we're also going to begin our loop counting at 0. And we also want our loop to end once it reaches 6. So for that reason, I'm making those 2 changes. And then inside here, we can leave these next lines alone. And in this part where we were mistakenly using if and if-else statements to take care of that, we can just simply replace this with using our array syntax. So here all I need to write is scanf, and again we're using the %f conversion, right, for floating point numbers. And then here I provide the address of, and then I specify that I'm referring to grade. And then what's really cool about using arrays is that the index can be a variable. So here I'm going to write in counter, because as we notice, this counter variable starts at 0 and it increases by 1 each time we go through the loop. It's increased by 1 here. So basically, as time goes on, counter will take on the value 0, 1, 2, 3, 4, and 5, enabling the user to fill in all of these grades. So let's finish this statement here. And then what we'll do down here is, instead of writing out all those lines again, in order to print out each grade one at a time, we can write a loop to do this. So let's go ahead and write a loop to do that. So again here, I'm going to set my counter back to 0. And then I'll write a while loop. Let's give us a couple lines here to work. While counter is less than 6. Okay, now we're going to display the grade at the current index. So here I'll just simply put printf. And I'll say grade. And I'll just tell the user which index we're looking at is, and then we'll have a second placeholder for the actual grade itself. So here I put new line, /n for new line, and now I'm going to put the variables I want to print out. First I'm going to print out the counter so that it fills in this placeholder to tell the user which grade we're currently printing out, and then I'm going to provide a variable for the grade itself. And as we know, the grades are stored at the current index here. Right. Once again, what's going to happen here is counter is going to start at 0. The loop will continue as long as the counter is less than 6, right? So count is going to go 0, 1, 2, 3, 4, 5. And of course, we have to remember down here to actually increase the count each time through the loop. So I can say counter plus plus down here, right? And plus plus, as I noted up here earlier in the code, plus plus is just simply shorthand for saying counter is equal to counter plus 1. All right, let's try out this code and see if it works for us. So I'm going to save my code. I'm going to compile it. And we got an error. So let's take a look at where that error might be. And of course here we see on line 26 of my program, I've forgotten something. And it's telling me that it's expecting a closing round brace at the end. So if you ever see errors, don't shy away from trying to figure out what those errors are and give up. Give it a little bit of a try first to figure out what the matter is. So here it's telling me on line 26, it's expecting a closing round brace. So if we go back to our code, right, one tip is in Nano, you can press Control-C to tell you which line we're on. Here at the bottom is telling us line 13. If I keep going to the bottom, we'll see line, here's line 27, here's line 26. And we found it, and we see that we need the closing brace here. So I'm going to compile once again. This time we have no errors, and I run my program, a.out. Actually, because I'm not on matrix, I'm going to type /a.out. If you're running this on matrix, then you don't need the /. So I'm going to run it. So the program is telling me that currently we're entering grade 0. Please enter the grade. So I'm going to use the basically use the examples that we had before. So 48.8 is the first grade. Now it's telling me enter grade 1, 91.1. Next grade is 76.4. Third grade is 80.1 and 62.9. Finally, 86.5. And then we see that we enter that second loop, which prints out all of the grades for us. And here I've lost my, there we are, I'm back. Okay, so I accidentally misclicked there, and then you see after we're done entering the grades, we enter that second loop that's going to print out and echo all of our grades. So that's, that's the very basics of using arrays in a nutshell, and we'll continue on with more complicated examples in the lab. So we'll see you in the workshop. In the meantime, I'll be uploading this example to GitHub so you can download it and play with it a little bit before the workshop, and stay tuned for your next quiz.